Welcome, SIGGRAPH. It is my first SIGGRAPH. I'm so excited to be here. I'm so excited to speak to all of you. And I'm so excited to speak to NVIDIA founder and CEO, Jensen Huang. Hi, Jensen. Great to see you again. Thank you. Great to see you.
Welcome to SIGGRAPH, Lauren.
Thank
Welcome
you.
to my hood.
You're a regular here,
Hey,
huh?
everybody. Great to see you guys.
Jensen, it is like 99 degrees outside.
I know, it's freezing in here, isn't it?
I mean,
I don't know, I'm shaking.
leather jacket.
Yeah, it feels great. Looks good, too.
All right, so you
I'm
have
wearing a brand new one.
a brand new one.
Yeah.
How many of those do you have?
I don't know, but Lori got me a new one for SIGGRAPH. She said, "You're excited about SIGGRAPH. Here's a new jacket. Go do a
Fantastic.
good job."
I look sharp.
Thank you.
All right. You have a long history of SIGGRAPH. I mean, when you think about the history of this conference, which has been going on since 1974, and you think about the history of NVIDIA from the 1990s onward, where your DNA was really in, computer graphics, helping to make beautiful graphics. What is the significance of NVIDIA being here today, right now, at a conference like SIGGRAPH?
Well, SIGGRAPH used to be about computer graphics. Now it's about computer graphics and generative AI. It's about simulation, it's about generative AI, and we all know that the journey of NVIDIA, which started out in computer graphics, as you said, really brought us here. And so I made a cartoon for you. I made a cartoon for you of our journey.
Did you make it, or did generative AI make it?
I had it, hang on a second. I had it made. I had it made. That's what CEOs do. We don't do anything, we just have it be done. It kind of starts something like this. Hey guys, wouldn't it be great if we had a cartoon and it illustrated some of the most important milestones in the computer industry and how it led to NVIDIA and where we are today? And so we illustrated.
And also do it in 3 hours.
And do it in 3 hours, right?
Yeah.
And so this cartoon here is really terrific. So these are some of the most important moments in the computer industry. The IBM System 360, of course, the invention of modern computing. The teapot, 1975. The Utah teapot, 1979. Ray tracing. Turner Whitted, one of the great researchers, NVIDIA researcher for a long time. 1986, programmable shading. Of course, most of the animated movies that we see today wouldn't be possible if not for programmable shading, originally done on the Cray supercomputer, led to, and then in 1993, NVIDIA was founded. Chris Curtis and I founded the company. 1995, Windows PC revolutionized the personal computer industry, put a personal computer in every home, at every desk. Multimedia PC was invented. 2001, we invented the first programmable shading GPU, and that really drove a vast majority of NVIDIA's journey up to that point. But at the background of everything we were doing was accelerated computing, and we believed that you could create a type of computing model that could augment the general purpose computing so that you can solve problems that normal computers can't. And the application we chose first was computer graphics, and it was probably one of the best decisions we ever made because computer graphics was insanely computationally intensive and remained so for the entire 31 years that NVIDIA has been here. And since the beginning of computer graphics, in fact, it required a Cray supercomputer to render some of the original scenes, so it kind of tells you how computationally intensive it was. And it was also incredibly high volume because we applied computer graphics to an application at the time that wasn't mainstream, 3D graphics video games. The combination of very large volume, very complicated computing problem led to a very large R&D budget for us, which drove the flywheel of our company. That observation we made in 1993 was spot on. And it led us to be able to pioneer the work that we're doing in accelerated computing. We tried it many times. CUDA was, of course, the revolutionary version, but prior to that, we had a computing model we call CG, C for graphics, C on top of GPUs. And so we've been working on accelerated computing for a long time. Promoting and evangelizing CUDA, getting CUDA everywhere, and putting on every single one of our GPUs so that this computing model was compatible with any application that was written for it, irrespective of which generation of our processors. That was a great decision. And one day in 2012, we made our first contact, Star Trek First Contact with artificial intelligence. That first contact was AlexNet and was in 2012. Very big moment. We made the observation that AlexNet was an incredible breakthrough in computer vision, but at the core of it, deep learning was deeply profound. That it was a new way of writing software. Instead of engineers given input, imagining what the output was going to be, write algorithms, we now have a computer that, given input and example outputs, would figure out what the program is in the middle. That observation, and that we can use this technique to solve a whole bunch of problems that previously wasn't solvable, was a great observation. And we changed everything in our company to pursue it. From the processor to the systems to the software stack, all the algorithms. NVIDIA Basic Research pivoted towards working on deep learning. By the way, this is a great place for research. As you know, NVIDIA is passionate about SIGGRAPH, and this year we have 20 papers that are at the intersection of generative AI and simulation. And so in 2016, we introduced the first computer we built for deep learning, and we called it DGX-1. And I delivered the first DGX-1 outside of our company. I built it for NVIDIA to build models for self-driving cars and robotics and such, and generative AI for graphics. But somebody saw an example of DGX-1. Elon reached out to me and said, hey, I would love to have one of those for a startup company we're starting. And so I delivered the first one to a company at the time that nobody knew about, called OpenAI. And so that was 2016. 2017 was the transformer that revolutionized modern machine learning, modern deep learning. In 2018, right here at SIGGRAPH, we announced RTX, the world's first real-time interactive ray tracing platform. We call it RTX. It was such a big deal that we changed the name of GTX, which everybody referred to our graphics cards as, to RTX. Another shout out for a great researcher. His name is Stephen Parker. Many of you know he's been coming to SIGGRAPH for a long time. He passed this year, and he was one of the core pioneer researchers behind real-time ray tracing, and we miss him dearly. And so, anyways.
And you mentioned last year during your SIGGRAPH keynote that RTX Ray Tracing Extreme was one of the big important moments when computer graphics met AI.
That's right.
But that had been happening for a while, actually. So what was so important about RTX in 2018?
Well, RTX in 2018, so we accelerated ray traversal and bounding box detection, and we made it possible to use a parallel processor to accelerate ray tracing. But even then, we were ray tracing at about, one frame every, call it, 10 frames maybe every second, let's say, maybe 5 frames every second, depending on how many rays we're talking about tracing. And we were doing it at 1080 resolution. Obviously, video games need a lot more than that. Obviously, real-time graphics need more than that.
And so this crowd definitely knows what that means, but for the folks who are watching online, who don't work in this field, I mean, this is basically a way of really manipulating light in computer graphics.
Simulating how a light interacts with
true to life,
versus through,
happening in real time.
That's right.
The rendering processes used to take a really long time when you were making something
It used to take a Cray supercomputer to render just a few pixels. And now we have our RTX to accelerate that ray tracing. But it was interactive, it was real time, but it wasn't fast enough to be a video game. And so we realized that we needed a big boost, probably something along the lines of 20x or so, maybe 50x or so boost. And so the team invented DLSS, which basically renders one pixel while it uses AI to infer a whole bunch of other pixels. And so we basically taught an AI that is conditioned on what it saw, and then say fills in the dots for everything else. And now we're able to render fully ray traced, fully path traced simulations at 4K resolution at 300 frames per second, made possible by AI. And so 2018 came along. 2022, as we all know, ChatGPT came out.
And what's that again?
ChatGPT,
Oh,
you know
okay,
that.
yes. Okay.
OpenAI's
Right.
ChatGPT,
Yep.
a revolutionary new capability AI, and fastest growing service in history. But the two things that I wanted to highlight since ChatGPT, the industry researchers, many of them in the room, has figured out how to use AI to learn everything, not just words, but to learn the meaning of images and videos and 3D, chemicals, protein, physics, thermal dynamics, fluid dynamics, particle physics. It's figured out the meaning of these, all these different modalities. And since then, not only have we learned it, we can now generate it. And so that's the reason why you can go from text to images, text to 3D, images to text, 3D to text, text to video, so on and so forth, text to proteins, text to chemicals. And so now generative AI has been made possible. And this is really the revolutionary time that we're in. Just about every industry is going to be affected by this, just based on some of the examples I've already given you, whether it's scientific computing, trying to do a better job predicting the weather with a lot less energy, to augmenting and collaborating with us creators to generate images, or generating virtual scenes for industrial digitalization, and very importantly, robotics, self-driving cars are all going to be transformed by generative AI. And so here we are in this brand new way of doing things. And so let me just very quickly, Lauren, if you look at where we started in the upper left in 1964, the way that software was programmed, human engineers programming software. Now we have machines that are learning how to program the software, writing software that no humans can, solving problems that we could barely imagine before. And now, because we have generative AI, a new way of developing software. I don't know if you know, do you know Andre Karpathy? He's a really, really terrific researcher. I met him when he was at Stanford, and he coined the original way of doing software 1.0, machine learning to be software 2.0. And now really we're moving towards software 3.0, because these generative AIs in the future, instead of using machine learning to learn a new AI for every researcher, you'll probably start with pre-trained models, foundation models that are already pre-trained. And the way that we develop software could very, very much be like assembling teams with experts of various AI capabilities, some that are using tools, some that are able to generate special things, and then a general purpose AI that's really good at reasoning, that's connecting this network of AIs together, solving problems like teams solve problems. And so software 3.0 is here.
I've gotten the sense from talking to you recently that you are optimistic that these generative AI tools will become more controllable, more accurate. We all know that there are issues with hallucinations, low quality outputs, that people are using these tools and they're maybe not getting exactly the output that they're hoping for.
Right.
Meanwhile, they're using a lot of energy, which we're going to talk about. Why are you so optimistic about this? What do you think is pointing us in the direction of this generative AI actually becoming that much more useful and controllable?
Well, the big breakthrough of ChatGPT was reinforcement learning human feedback, which was the way of using humans to produce the right answers, or the best answers, to align the AI on our core values, or align our AI on the skills that we would like it to perform. That's probably just the extraordinary breakthrough that made it possible for them to open ChatGPT for everyone to use. Other breakthroughs have arrived since then. Guardrailing, which causes the AI to focus its energy or focus its response in a particular domain, so that it doesn't wander off and pontificate about all kinds of stuff that you ask it about. It would only focus on the things that it's been trained to do, aligned to perform, and that it has deep knowledge in. The third breakthrough is called retrieval augmented generation, which basically is vectorized or data that has been embedded so that we understand the meaning of that data. And so
It's a more authoritative data set.
It's
It
a
goes
thor-
beyond
that's
just
right.
the trained data set, and it
That's
actually
right.
pulls from other sources.
That's right. It's
So
not just
supposedly it's
pre-trained
going
data
to be-
source.
Right.
It's and something, for example, it might be all of the articles that you've ever written, all of the papers that you've ever written. And so now it becomes an AI that's authoritative on your, and it could be essentially a chatbot of you. So everything that I've ever written or ever said could be vectorized and then created into a semantic database. And then before an AI responds, it would look at your prompt, and it would search the appropriate content from that vector database, and then augment it in its generative process.
And you think that that is one of the most important factors.
These three combinations really made it possible for us to do that with text. Now, the thing that's really cool is that we are now starting to figure out how to do that with images,
visuals.
right? And SIGGRAPH is really a lot about images and generation. And so if you look at today's generative AI, you could give it a prompt, and it goes into, in this particular case, this is a Edify AI model that Nvidia created. It's a 2D, text to 2D foundation model. It's multimodal, and we partnered with Getty to use their library of data to train an AI model. And so this is a text to 2D image. And
You also created this slide personally, right?
I personally had this slide created. And so imagine I'm the prompt, and then there's a team that's kind of like a generative AI, and then magically this slide shows up. And so here's a prompt, and this could be a prompt for somebody who owns a brand. It could be a brand of, in this case, Coca-Cola. It could be a car. It could be a luxury product. It could be anything. And so you use the prompt and generate the image. However, as you know, it's hard to control this prompt, and it may hallucinate. It may create it in such a way that it's not exactly what you want. And to fine-tune this using words is really, really hard, because as you know, words is very low dimensionality. It's extremely compressed in its content, but it's very imprecise. And so the ability for us to now control that image is difficult to do. And so we've created a way that allows us to control and align that with more conditioning. And so the way you do that is we create another model. And this model, for example, allows us to text to 3D. On the bottom, it's Edify 3D, one of our foundation models. We've created this AI foundry where partners can come and work with us, and we create the model for them with their data. We invent the model, and they bring their data, and we create a model that they can take with them.
Is it
and so
only using their data?
Only uses their data. So this only uses all of the data that's available on Shutterstock that they have the rights to use to train. And so we now use prompt generator 3D. We put that in Omniverse. Omniverse, as you know, is a place where you could compose data and content from a lot of different modalities. It could be 3D, it could be AI, it could be animation, it could be materials. And so we use Omniverse to compose all of these multimodality data, and now you can control it. You could change the pose, you could change the placement, you could change whatever you like, and then you use that image out of Omniverse to condition the prompt. Okay, so you take what comes out of Omniverse, you now augment it with the prompt. It's a little bit like retrieval augmented generation. This is now 3D augmented generation. Getty, the Edify model is multimodal, so it understands the image, understands the prompt, and it uses it in combination to create a new image. So now this is a controlled image. And so this way we can use generative AI as a collaborator, as a partner to work with us, and we can generate images exactly the way we like it.
How does this translate to the physical world? How does it translate to something like robotics?
Well, we're going to talk about robotics, but one of the things that I would love to show you, and I had this made not by myself, well, I had it made myself. Okay, this is an incredible video, and this is a work that is done by WPP, Shutterstock, working with some of the world-class, world-famous brands that you'll know. Let's run the video. Let's show the.
Build me a table in an empty room, surrounded by chairs, in a busy restaurant. Build me a table with tacos and bowls of salsa in the morning light. Build me a car on an empty road, surrounded by trees. Buy a modern house. Build me a house with hills in the distance and bales of hay in the evening sun. Build me a tree in an empty field.
Build me hundreds of them in all directions, with bushes and vines hanging in between. Build me a giant rainforest with exotic flowers and rays of sunlight.
Isn't that incredible? And this is what happened. We taught an AI how to speak USD, OpenUSD. And so the girl is speaking to Omniverse. Omniverse generates the USD and use USD search to then find the catalog of 3D objects that it has. It composes the scene using words, and then generative AI uses that augmentation to generate, to condition the generation process, and so therefore the work that you do could be much better controlled. You could even collaborate with people because you can collaborate in Omniverse and you can collaborate in 3D. It's hard to collaborate in 2D, and so we can collaborate in 3D, augment the generation process.
I imagine a lot of people in this room who aren't just technical, but they're also storytellers.
This is a very technical room.
Storytellers see something like this.
There's like 90% PhDs in here.
And think, I'm not even going to ask you to do a raising of your hand, but I'm sure that would be fascinating. So they see something like this. I see something like this, and I think, oh, okay, that's pretty amazing. You are speeding up rendering times. You're creating images out of nothing. There are probably just as many people thinking, what does this mean for my job? Where do you draw the line between this is augmenting and helping people? Where do you see the line being drawn? And this is replacing certain things that humans do.
Well, that's what tools do. We invent tools here. This conference is about inventing technology that ultimately ends up being a tool. And that tool either accelerates our work, collaborates with us so that we could do better work or even bigger work, do work that's impossible before. And so I think what you'll likely see is that generative AI is now going to be more controllable than before. We've been able to do that with using RAGs, retrieval augmented generation, to control text generation better, reducing hallucination. Now we're using Omniverse with generative AI to control generative images better and reduce hallucination. Both of those tools help us be more productive and do things that we otherwise can't do. And so I think for all of the artists in the world, what I would say is jump on this tool, give it a try, imagine the stories that you're going to be able to tell with these tools, and with respect to jobs, I would say that it is very likely all of our jobs are going to be changed.
In what way?
Well, my job is going to change. The way in the future, I'm going to be prompting a whole bunch of AIs. Everybody will have an AI that is an assistant. And so every single company, every single job within the company will have AIs that are assistants to them. Our software programmers, so you know, now have AIs that help them program. All of our software engineers have AIs that help them debug software. We have AIs that help our chip designers design chips. Without AI, Hopper wouldn't have been possible. Without AI, Blackwell wouldn't be possible. This week we're sampling, we're sending out engineering samples of Blackwell all over the world.
They're under people's chairs right now. I think if you just look, you get a GPU. And
you and I, yeah,
GPU.
you get a GPU. You get a GPU. Yeah, that's right.
Supply chain.
We all wish.
Yeah.
Yeah, and so none of the work that we do would be possible anymore without generative AI, and that's increasingly the case with our IT department helping our employees be more productive. It's increasingly the case with our supply chain team optimizing supply to be as efficient as possible, or our data center team, using AI to manage the data center to save as much energy as possible.
You mentioned Omniverse before.
Yeah.
That's not new, but the idea that more generative AI would be within the Omniverse, helping people create these simulations or digital twins.
Yeah, that's what we're announcing this week, by the way.
So talk about that.
Omniverse now understands text to USD. It could understand text to, and has a semantic database so that it could do search of all the 3D objects. And that's how that young lady was able to say, fill the scene with a whole bunch of trees, describing how she would like the trees to be organized, and somehow populates it with all these 3D trees. Then when that's done, that 3D scene then goes into a generative AI model, which turns it into a photorealistic model. And if you want the Ford truck to not be augmented, but to use the actual brand ground truth, then it would honor that and keep that in the final scene. And so I think if you do that, so one of the things that we talked about is how every single group in the company will have AI assistants, and there's a lot of questions lately about whether all this infrastructure that we're building is leading to productive work in companies. I just gave you an example of how generative AI is impossible without Nvidia's designs would be impossible without generative AI. So we use it to transform the way we work. But we also use it in many examples that I've just shown you in creating new products and new technology that either makes possible ray tracing in real time, or Omniverse that we can now imagine and help us create much larger scenes, or our self-driving car work or our robotics work. None of that new capability would be possible without it. And so one of the things that we're announcing here this week is the concept of digital agents, digital AIs that will augment every single job in the company. And so one of the most important use cases that people are discovering is customer service. And every single group, every single company has customer service. Every single industry has customer service. And in the future, today it's humans doing customer service, but in the future, my guess is that it's going to be human still, but AI in the loop. And the benefit of that is that you'll be able to retain the experiences of all the customer service agents that you have, and capture that institutional knowledge that you can then run into analytics, that you can then use to create better services for your customers. Just now I showed you a Omniverse augmented generation for images. This is a RAG. This is a retrieval augmented generative AI. And the thing that we're doing is we've created this customer service, basically microservice that sits in the cloud. And it's going to be available, I think, today or tomorrow. And you can come and try it. And we connected to it a digital human front end, basically an I/O. The I/O of an AI that has the ability to speak, make eye contact with you, animate in an empathetic way, and you could decide to connect your ChatGPT or your AI to the digital human, or you could connect your digital human to our retrieval augmented generation customer service AI. So however you like to do it, we're a platform company. So irrespective of which piece you would like to use, they're completely open source, and you can come and use the pieces that you like. If you would like the incredible digital human rendering technology that we've created for rendering beautiful faces, which requires subsurface scattering with path tracing, this breakthrough is really quite incredible, and it makes it possible for us.
Amazing graphics researchers, welcome to SIGGRAPH 2024.
So it makes it possible to animate using an AI. So you chat with the AI, it generates text. That text then is translated to sound, text to speech. That speech, the sound, then animates the face, and then RTX path tracing does the rendering of the digital human. And so all of this is available for developers to use, and you could decide which parts you would like to use.
How are you thinking about the ethics of something like this? You're unleashing this to developers, to graphics artists, but these are being unleashed into the world.
Yep.
Do you think a chatbot like that, a very human-like visual chatbot, should say that it's a chatbot? Is it so human that people start mistaking it for humans? They're emotionally vulnerable to a chatbot.
It's still pretty robotic, and I think that that's not a terrible thing. You know, we're going to be robotic for some time. I think we've made this digital human technology quite realistic, but you and I know it's still a robot, and so I think that's not a horrible way. It is the case that there are many different applications where the human engagement is much more engaging, having a human representation or near human representation than a text box. Maybe somebody needs companion, or healthcare needs to advise somebody who is an outpatient who had just gone home. Helping elderlies. There's a whole bunch of applications. A tutor, to educate a child. All these different applications are better off having somebody who is much more human and being able to connect with the audience.
That's interesting.
Yeah.
What I hear you talking a lot about today, these are software developments, right? They're relying on your GPUs, but ultimately, this is software. This is Nvidia going further up the stack. Meanwhile, there are some companies, some folks in the generative AI space who are in software and cloud services, but they're looking to go further down the stack, right? They might be developing their own chips or TPUs that are competitive with what you are doing. How crucial is this software strategy to Nvidia maintaining its lead and actually fulfilling some of these promises of growth that people are looking at for Nvidia right now?
Well, we've always been a software company, and even first. And the reason for that is because accelerated computing is not general purpose computing. General purpose computing can take any C program, a C++ program, Python, and just run it. And almost everybody's program can be compiled to run effectively. Unfortunately, when you want to accelerate fluid dynamics, you have to understand the algorithms of fluid dynamics so that you could refactor it in such a way that it could be accelerated. And you have to design an accelerator. You have to design the CUDA GPU so that it understands the algorithms so that it could do a good job accelerating it. And the benefit, of course, is that we can, by doing so, by redesigning the whole stack, we can accelerate applications 20, 40, 50 times, 100 times. For example, we just put NVIDIA GPUs in GCP running Pandas, which is the world's leading data science platform. And we accelerated from 50 to 100x over general purpose computing. In the case of deep learning, over the course of the last 10 to 12 years or so, we've accelerated deep learning by 1 million times, which is the reason why it's now possible for us to create these large language models. 1 million times speed up, 1 million times reduction in cost and energy is what made it possible for us to make generative AI possible. But that's by designing a new processor, a new system, Tensor Core GPUs. The NVLink switch fabric is completely groundbreaking for AI. Of course, the systems itself, the algorithms, the distributed computing libraries we call Megatron that everybody uses, TensorRT, LLM, those are algorithms, and if you don't understand the algorithms, the applications above it, it's really hard to figure out how to design that whole stack.
What is the most important part of NVIDIA's software ecosystem for NVIDIA's future?
Well, every single one of it takes a new library. We call it DSLs, domain-specific library. In generative AI, that DSL is called cuDNN. For SQL processing, data frames, it's called cuDF. And so if you go to SQL, Pandas, cuDF is what makes it possible for us to accelerate that. For quantum emulation, it's called cuQuantum. cuFFT, we got a whole bunch of cu's. Computational lithography, which makes it possible for us to help the industry advance the next generation of process technology, called cuLitho. The number of cu's goes on and on. Every time we introduce a domain-specific library, it exposes accelerated computing to a new market. And so, as you see, it takes that collaboration, the full stack of the library and the architecture and the go-to-market and the developers and the ecosystems around it to open up a new field. And so it's not just about building the accelerator. You have to build the whole stack.
NVIDIA is dependent on a lot of things going right. Your foray into the future, your innovation depends on a lot of things going right. You have to continue pushing the laws of physics. You do have competitors who are nipping at your heels at all times. We've talked about this, what keeps you up at night. You're also somewhat reliant on the geopolitical stability.
Last night, just so you know, elevation.
Drink some water.
That's what they told me, but
here.
it was too late. By the time I learned about it this morning, I woke up with a terrible headache. Elevation, that's what was last night.
Okay, so elevation, but truly, you have to keep pushing the laws of physics. You have competitors who are nipping at your heels, both on the software and hardware side. You are somewhat reliant on the geopolitical stability of the South China Sea, geopolitics, so much going on right now.
You're reminding me, it's super hard building a company.
It is. But you've had a lot
You're making me nervous. I was fine before. There's so many things that
he wants
we have
to go back
do.
to showing you slides. But truly, you've had a lot of tailwinds, and I'm just, how optimistic are you that these things are going to keep trending in your direction?
Things have never trended in our direction. You have to will the future into existence. Accelerated computing, the world wants general purpose computing, and the reason for that is because it's easy. You just have the software, it just runs twice as fast every single year, don't even think about it. And every 5 years is 10 times faster, every 10 years is 100 times faster. What's not to love? But of course you could shrink a transistor, but you can't shrink an atom, and eventually the CPU architecture ran its course. And so it's not sensible anymore, as the technology doesn't give us those leaps, that a general purpose instrument could be good at everything. Could be good at these incredible things from deep learning to quantum simulation to molecular dynamics, to fluid dynamics, right, so on, to computer graphics. And so we created this accelerated computing architecture to do that. But that's headwind. Do you see what I'm saying? Because general purpose computing is the easy way to do it. We've been doing it for 60 years. Why not keep doing it? And so accelerated computing was only possible because we deliver such extraordinary speed-ups at a time when energy is becoming more scarce, at a time when we no longer could just ride the CPU curve any longer. Dennard scaling has really ended, and so we need another approach, and that's why we're here. But notice every single time we want to open up a new market like cuDF in order to do data processing. Data processing is probably a third of the world's data, a third of the world's computing. Every company does data processing, and most companies' data is in data frames, in tabular format. And so in order to create an acceleration library for tabular formats was insanely hard because what's inside those tables could be floating point numbers, 64-bit integers. It could be, numbers and letters and all kinds of stuff. And so we have to figure out a way to go compute all that. And so you see that almost every single time we want to grow into something, you have to go and learn it. That's the reason why we're working on robotics. That's the reason why we're working on autonomous vehicles, to understand the algorithms that's necessary to open up that market and to understand the computing layer underneath it so that we can deliver extraordinary results. And so, as you could see, each time we open up a new market, healthcare, digital biology, the amazing work we're doing there with BioNemo and Parabricks for gene sequencing, every single time we open up a new market, it just requires us to reinvent everything of that computing. And so there's nothing easy about it.
Generative AI takes up a lot of energy.
I'm just saying, my job's super hard.
But your assistants, your AI assistants are going to make it easier, right?
What's that? Somebody's got to pat my back. Hey, a little applause, you guys. Cheer them on. Yeah, go ahead.
Let's talk about energy.
Yeah.
Generative AI, incredibly energy intensive.
Yep.
I am going to read from my note cards here. According to some research, ChatGPT, a single query takes up nearly 10 times the electricity to process a single Google search. Data centers consume 1% to 2% of overall worldwide energy, but some say that it could be as much as 3 to 4%. Some say as much as 6% by the end of the decade. Data center workloads tripled between 2015 and 2019. That was only 2019. AI, generative AI, is taking up a large portion of all of that. Is there going to be enough energy to fulfill the demand of what you want to build and do?
Yeah, yes. And a couple of observations. So first, there are two or three or four model makers that are pushing the frontier a couple of years ago. There are probably 3 times that many this year, but it's still single digit. It's a very high single digit, but call it 10, that are pushing the frontiers of models. And the size of the models are, call it twice as large every year, maybe faster than that. And in order to train a model that's twice as large, you need more than twice as much data. And so the computational load is growing probably by call it a factor of 4 each year, just for simple thinking. Now that's one of the reasons why Blackwell is so highly anticipated, because we accelerated the application so much using the same amount of energy. And so this is an example of accelerating applications at constant energy, constant cost. You're making it cheaper and cheaper and cheaper. Now, the important thing, though, is I've only highlighted 10 companies. The world has tons of companies, and there are data centers everywhere. And NVIDIA is selling GPUs to a whole lot of companies and a whole lot of different data centers. And so the question is, what's happening? At the core, the first thing that's actually happening is the end of CPU scaling and the beginning of accelerated computing. Data processing, just text completion, speech recognition, all of those kind of basic AI things that are used, recommender systems that are used in data centers all over the world. Everyone is moving from CPUs to accelerated computing because they want to save energy. Accelerated computing helps you save so much energy, 20 times, 50 times in doing the same processing. So the first thing that we have to do, as a society, is accelerate every application we can. If you're doing Spark data processing, run it with accelerated Spark so that you could reduce the amount of energy necessary by 20 times. If you're doing SQL processing, do SQL, accelerated SQL so that you could reduce the power by 20 times. And so if you're doing weather simulation, accelerate it. When you're doing whatever scientific simulation you're doing, accelerate it. Image processing, accelerated. A lot of those applications used to be running on CPUs and general purpose computing. All of that should be accelerated going forward. That's the first thing that's happening. Now, is that reducing the amount of energy being used all over the world? Absolutely. the density of our GPUs and density of accelerated computing is higher, energy density is higher, but the amount of energy used is dramatically lower. So that's the first thing that's happening. Of course, then generative AI. Generative AI is probably consuming, let's pick a very large number, probably 1% or so of the world's energy. But remember, even if the data centers consume 4% of the world, the goal of generative AI is not training. The goal of generative AI is inference. And the inference, ideally, we create new models for predicting weather, predicting new materials, allow us to optimize our supply chain, reduce the amount of energy consumed and wasted gasoline as we deliver products. And so the goal is actually to reduce the energy consumed of the 96%. And so very importantly, you have to think about AI from a longitudinal perspective, not just going to school, but what happens after going to school. You and I both went to Stanford. Stanford's not inexpensive.
I think you studied something slightly different, though.
Yeah, sure. It's a big school.
It's worked out well for you.
It's worked out well for both of us. And so, so the goal, of course, is going to school is important. But of course, the important thing is really after school and all of the contributions that we're able to make to society. And so generative AI is going to increase productivity. It's going to enable us to discover new science, make things more energy efficient. Don't let me finish without showing you the next. And so that
Also,
accelerated
the
computing.
lights just came on because we were talking about energy, and all of a sudden it's like the Earth was like, okay. Tamp down the energy usage, folks.
I thought they were. Am I getting chased out of my own?
I think we still have a few minutes,
okay.
so I mean, I hope so. I mean, I'm not going to get off the stage until Mark Zuckerberg comes on here and kicks me off. How about that?
He's not going to do that. He's a great guy. So, anyways, think about generative AI longitudinally and all the impact of generative AI. The second thing, the next thing I'll say about generative AI is remember. The traditional way of doing computing is called retrieval-based computing. Everything is pre-recorded. All the stories are written pre-recorded. All the images are pre-recorded. All the videos are pre-recorded. And so everything is stored off in a data center somewhere, pre-recorded. Generative AI reduces the amount of energy necessary to go run to a data center over the network, retrieve something, and bring it over the network. Don't forget, the data center is not the only place that consumes energy. The world's data center that is only 40% of the total computing done. 60% of the energy is consumed on the internet, moving the electrons around, moving the bits and bytes around. Mm-hmm. And so generative AI is going to reduce the amount of energy on the internet because instead of having to go retrieve the information, we can generate it right there on the spot because we understand the context. We probably have some content already on the device, and we can generate the response so that you don't have to go retrieve it somewhere else.
Well, part of that is also moving atoms around, right?
And then
part
one
of that
last
is supply chain.
One last thing I got to tell you.
Okay.
Lauren, one last thing I tell you. Remember, AI doesn't care where it goes to school. Today's data centers are built near the power grid where society is, of course, because that's where we need it. In the future, you're going to see data centers being built in different parts of the world where there's excess energy. It's just that it costs a lot of money to bring that energy to society. Maybe it's in a desert, maybe it's in places that has a lot of sustainable energy, but it's just not a very attractive.
They're already taking up a lot of water.
Well, there's plenty of water as well. It just happens to be undrinkable water, and so we can use water that are we can put data centers where there's less population and more energy. Okay, just don't forget that there's a lot of energy coming from the sun. There's a lot of energy in the world, and what we need to do is move data centers out closer to where there's excess energy and not put everything near population.
Well, and
AI doesn't care where it's trained.
I'd never heard that phrase before. AI doesn't care where it goes to school, and that's interesting.
Yeah, it's true.
I'm going to think on that.
Yeah.
Part of calculating the carbon emissions, though, is also considering the supply chain. It's also considering it's going all down the line, and it requires transparency.
Don't move the energy to the data center. Use the energy where the data center is, and then when you're done, you have a highly compressed model that is essentially the compression of all the energy that was used, and we can take that model and bring it back. Hey, can we talk about the next wave? So the first wave, of course, the first wave is accelerated computing.
I think he's going to do it.
I know that she's the interviewer, and we're doing this on her terms, but I'm the CEO, so and so no, Lauren, we need to come and tell this group about the work that we're doing that is really core to them.
I have so many good questions for you.
I know.
I want to ask you about open source, which I think you're going to be talking to Mark about. I want to ask you about. I have an important.
By the way, open source
Yeah.
is really important. It's incredible. Yeah. And if not for open source, how would all of these industries and all these companies be able to engage AI? And so look at all the companies and all the different industries. They're all using Llama 2 today. Llama 3.1 just came out. People are so excited about it. We've made it possible to democratize AI and engage every single industry in AI. But the thing that I want to say is this: the first wave is accelerated computing reduces energy consumed, allows us to deliver continued computational demand without all of the power continuing to grow with it. So number one, accelerate everything. It made it possible for us to have generative AI. The generative AI, the first wave of it, of course, is all the pioneers. And we know many of the pioneers: OpenAI, Anthropic, Google, Microsoft, a whole bunch of amazing companies doing this. X is doing this, X.AI is doing this, amazing companies doing this. The next wave of AI we didn't talk about, which is enterprise. Of course, one of its applications is customer service, and we hope that we can give every single organization the ability to create their own AIs. And so everybody would be augmented and have a collaborative AI that could empower them, help them do better work. The next wave of AI after that is called physical AI. And this is really quite extraordinary. This is where we're going to need 3 computers. One computer to create the AI, another computer to simulate the AI, both using for synthetic data generation, as well as a place where the AI robot, the humanoid robot or the manipulation robot, could go learn how to refine its AI. And then, of course, the third AI is the computer that actually runs the AI. So it's a three computer problem. It's a 3-body problem. And so it's incredibly complicated, and we created 3 computers to do that. And we made a video for you to enjoy understanding this. The thing that we've done here is this: each one of these computers, depending on whether you want to use the software stack, the algorithms on top, or just the computing infrastructure, just the processor for the robot, or the functional safety operating system that runs on top of it, or the AI and computer vision models that run on top of that, or just the computer itself. Any layer of that stack is open for robotics developers. We created a quick video. Let's take a look at that. Is that okay?
That sounds great.
The era of physical AI is here. Physical AI, models that can understand and interact with the physical world, will embody robots. Many will be humanoid robots. Developing these advanced robots is complex, requiring vast amounts of data and workload orchestration across diverse computing infrastructures. NVIDIA is working to simplify and accelerate developer workflows with 3 computing platforms: NVIDIA AI, Omniverse, and Jetson Thor, plus generative AI-enabled developer tools. To accelerate Project Groot, a general humanoid robot foundation model, NVIDIA researchers capture human demonstrations, seeing the robot's hands in spatial overlay over the physical world. They then use RoboCasa, a generative simulation framework integrated into NVIDIA Isaac Lab, to produce a massive number of environments and layouts. They increase their data size using MimicGen NIM, which helps them generate large-scale synthetic motion datasets based on the small number of original captures. They trained the Groot model on NVIDIA DGX Cloud with the combined real and synthetic datasets. Next, they perform software-in-the-loop testing in Isaac Sim in the cloud and hardware-in-the-loop validation on Jetson Thor, before deploying the improved model to the real robots. NVIDIA Osmo Robotics Cloud Compute Orchestration Service manages job assignment and scaling across distributed resources throughout the workflow. Together, these computing platforms are empowering developers worldwide to bring us into the age of physical AI-powered humanoid robots.
You know what's amazing, Lauren? At this conference, SIGGRAPH, is where all of this technology comes together. Isn't that right? Everybody? Researchers of SIGGRAPH, isn't that right? So whether it's computer graphics or simulation, artificial intelligence, robotics, all of it comes together right here at SIGGRAPH, and that's the reason why I think you should come to SIGGRAPH from now on.
Me?
Yes.
Oh, I'm happy to. I'm thrilled to.
Am I right?
I took
Everybody?
a look around. I went and
100% of the world's tech press should come to SIGGRAPH.
We can get behind that. Just drink a lot of water. I went and saw some of the art exhibits last night upstairs in the exhibition effort. Fantastic.
Incredible.
Just really, really cool. Loved the literal spam bots, whoever created that one. Go check it out. I was actually listening to the SIGGRAPH Spotlight podcast before this. If folks haven't listened, I really recommend it. The Special Projects Chair was interviewing a couple of graphics legends, including David Yem.
Yeah.
And one of the things that David M. talked about was archives. And this is kind of an existential question for this crowd, right? But people are creating this really amazing digital media, all of these computer graphics. You are accelerating it with your technology. It changes so fast now. How do you ensure that everything folks are building lives into the future? File formats, archives, accessing all of this work in the future. The robots will live on.
Yep.
I have no concern. They're going to take over.
Yep.
Right?
Yep.
What about the art that people are creating? This is the existential question.
Well, one of the that's an excellent question, and one of the formats that we deeply believe in is OpenUSD. OpenUSD is the first format that brings together multimodality from almost every single tool and allows it to interact, to be composed together, to go in and out of these virtual worlds. And so you could bring in just about any format, ideally, over time into it. At this conference, we announced that URDF, the Universal Robotics Data Format, is now compatible with, or it can be ingested into OpenUSD. And so one format after another format, we're going to bring everything into this one common language. Using standards is one of the best ways to allow content and data to be shared, allow everybody to collaborate on it and to live forever. For example, HTML. Without HTML, it would have been hard for all of these different content from around the world to be accessible to everybody. And so in a lot of ways, OpenUSD is the HTML of virtual worlds. And we've been an early promoter of it. There's amazing companies that have joined and many other companies joining. And my expectation is every single design tool in the world will be able to connect to OpenUSD. And once you connect to that virtual world, you can collaborate with anybody with any other tool anywhere. And so just like we did with HTML.
You said this content can live forever. Are you going to build a Jensen AI that lives forever?
Absolutely, there's a Jensen AI. In fact, just about everything that I've ever said, everything that I've ever written and ever done will likely be ingested into one of these generative AI models. And I'm hoping that happens. And then in the future, you'll be able to prompt it and hopefully something smart gets said.
So Jensen AI is going to be running your earnings calls in the future.
I hope so. That's the first thing that has to go. That's the first thing that has to go to a bot.
Jensen, thank you so much. I think we're probably going to get kicked off stage soon, but you'll be back shortly with Mark Zuckerberg. So
yes, and welcome to your first SIGGRAPH.
Thank you. This has
Ladies
been
and
great.
gentlemen, Lauren Good.
Thank you. It's really great chatting again.
Thank you, everybody. We'll be right back.